Hi guys. I've gonna put up a quick, a very easy finding an angle question, which you usually find in, I believe it's a C3 paper. So the question we're worried about today is we're trying to find a value for x in between 360 and 0. Um, Theoretically, my x should be the same as this theta here. I should have put them as both the same, but it doesn't really matter in this case. But just for purposes, we'll say that x does equal theta as well, because I do interchange them a lot in this example, but it's not a big deal. So starting off with a question like this, what we are worried about of finding this x value in between 360 degrees and 0 degrees is we have to find the primary angle of x. Yeah. So the first step in this process is to find this value of x. And how do we do this? Well, we have to find the primary angle by doing what we call either an arctan or a tan minus 1. They're both the same in this case, but they are different. They're not the same. But I was taught at school to put arctan x to find a primary angle, which is 45, which we know is 45 degrees by just primary angles. Yep. So once we have our primary angle, it's 45 degrees. So that's the first angle we are worried about. But remember, we are going from 0 to 360 degrees. Yeah. So by using our cast diagram, yep. So I'll just say one thing, as to take into account that we are working with a positive 1, yeah? And whenever we're working with a positive number, we are interested in the all quadrant and the tan quadrant. If this one was minus, we'd be interested in the cos and sine, because that is where tan is a minus value, yeah? The angle of tan would give a minus value, yeah? So we switch over. Yep. So as I explained in the previous video, when working with a cast diagram, we always work from the horizontal line, yeah, from 0 to 180 degrees, yeah, with 90 up there, 270. This would also be 360. Yep. So as we found the primary angle, we have 45 degrees. Yep. So that's our first angle. So as to find the tan value, well, if we add 45 degrees to 180, yep, so I've added that, we ended up with 225. Yep, so add 20, add another 25 will give us 225, yep. So if we go back to the actual question, so we have two values, so x would equal 45 degrees or 225 degrees, yep. So basically, if we go over again, so if we add another 360 to 45, we'd go over the value. We'd be over the value of 360, yes? So that would be out of bounds. So we're only left with these two values, which is our final answer. And now we have these two values between 0 and 360. Say if this was longer, say if it was 720 or double that, yeah? So all we'd have to do to find the corresponding angles in the boundaries would be adding 360s to these two values, yeah? And I hopefully will put a video up with a bigger boundary soon to show you how that works, and maybe a more complex trig function. But most of them are, you'd have to, so say if I had something weird like sine x squared plus cos x squared plus something else, it's usually just breaking them back down into the elementary functions and using just simple trig identities. I'm hopefully going to bring out a video of trig identities and how useful they are in integration soon as well, so please stay tuned for that. But I hope you understand this. If there's any questions, please leave them in the comment box, but thank you very much.